Okay, so another use for factorials is using to expand a binomial. Okay, so you're going to use these factorials. It's called binomial theorem. Anyway, so let's talk about what it means to expand a binomial. Okay, so first of all, a binomial is something like this, right? X plus y to the nth power. Okay, so this is a binomial that needs to be expanded. So let's take an example. I'm going to take, we're going to take an example, and the first example that we're going to take is x plus y squared. Okay, so we take x plus y squared, and this equals x plus y times x plus y. All right, so we would take this, and you guys know, because we've done this over and over this year, right? As you multiply it out, you get x squared plus x times y plus x times y. Oh, wait. No, sorry. It's doing something else at the same time, and it wanted to jump in there. And then you have the y squared. Okay, so we're left with x squared plus 2xy plus y squared. Okay, now we can calculate that, and that actually takes a while, and that's just a squared. So what happens when you have x plus y to the 10th power, or x plus 3 to the 10th power? So what I want you to notice, first of all, is that your first term, x squared, it goes from x squared, x to the first, sorry, let's look at this one, that's all simplified down, okay? It goes from x squared, x to the first, x to the 0, because x to the 0 would equal 1, and that's why it doesn't show up here, right? The y starts at 0 and goes up to y to the first and y squared, okay? So they kind of work opposite directions with each other when you have a binomial here that both have variables. Now, if it has just one variable, then you would go through here, and this would give you x squared plus 2x plus 1. Okay, so on this case, it still moves down. Your first variable would be x squared, x to the first, x to the 0, and there's no variable here, so that wouldn't come back the other direction. But when there's variables on both sides, it does go in both directions. So that's important to know, because I think that's why it looks so confusing when we talk about the binomial theorem. Okay, so let's look at the binomial theorem now, because we don't want to calculate. If I give you x plus 1 to the 10th power, that means that you are going to do x plus 1 times x plus 1, and you're going to FOIL that. Then you're going to take your answer to that, and you're going to distribute and multiply every term from those two by every term in this one, and by every term, and then you take that answer and multiply every term in that one by x, and every term in that one by 1, and every term in that one by x, and every term in that one by 1, and you're going to have to multiply out 10 times. 1, 2, 3, 4, 5, yeah, that is so much work. So it's a ton of work, and you need to understand that, so that when you get into doing binomial theorem, you'll appreciate, even though it's a little bit of work, it's a lot less than you would have to do. Okay, so the binomial theorem tells us that if you have a binomial, and we're going to call it just generically x plus y, so x would be whatever's in that first position, and y is whatever's in this position. And remember, it has a plus sign between it. So if you have like 4x minus 3, you need to make sure that your y value is negative 3. So I'm going to take and write out what this is. So first of all, remember that we have been doing the summation, right? Summation's coming back. So we have a summation, and we're going to go from when k equals 0. Now, this is where I'm glad we talked a little bit about the summations more, and hopefully the things will start making sense. On the binomial theorem, you start with k equals 0. because we need that to happen so that you have those constant terms also, and you'll see what I mean in a second. But we're going to give a formula for what the summation is. Now, if you look at this, why it's a summation is because this would be the first term plus the next term plus the next term. It is a summation. When you expand a binomial, it's terms added together. So what this is this is going to be a formula for us finding each term, and we have to start with k equals 0, because that's going to give us our term that that starts as a 0. Okay, so here we're going to do, and this is where this notation is also going to come. If you take n k at a time, and you do x to the k and y to the n minus k. Okay, now I have seen the two of these reversed, but this is what I'm going to tell you, is that as long as you are doing it, and let me double check. Let me actually double check one thing. Okay, so I double checked it. I've seen this both ways, where I have x is n minus k and y is just k. Now, if you either way you do it, it actually comes up with the same answer, but it comes up in the right order if you do it this other way around. So we're going to switch this to n minus k here. But don't freak out if you see it the other way around, okay? So it's okay to have x to the n minus k and y to the k. Okay, so this takes a little bit of work, so I'm going to move to the next page and we're going to go through a problem. But remember this, this formula right here, and actually I think I'm going to take it with us. Okay, so we're going to start with expanding one that's kind of smaller because it is a lot of work to find each term as we go out. And then we're going to do one example of just finding one term and how to do that. Okay, so first of all, this one, you could do it regularly, and I know that, but when you get into something bigger, you won't be able to. We're just doing this because it's a smaller one, okay? So what this is first you would set it up as with your binomial theorem, okay? So you're saying, okay, this is the binomial that I'm going to expand to the third power, okay? Now remember, 3 is my n, okay? That's my n. My x is the 2x, and my y is a negative 3. Okay, so I'm going to take my summation. You're going to say, okay, I'm going to start with k equals 0. Until you better understand things, yeah, and in the next example, I guess we will change k. But we're going to do that in this one, but just always set it up like this with k equals 0. Your n value is 3. And then on here, remember your n value is 3. And we're making a formula for the summation. Remember how this value, the k value that we plug in, tells us which term we're on, because there's 3 terms. There's actually 4 terms, right, because of the 0. Now let's talk about that for a second. Before, when we started out k equals 1 and went to 3, there were 3 terms. You had the 1 when you plugged in 1, 2, and 3. If you start at 0, you plug in 0, 1, 2, and 3, and so there's going to be 4 terms. This has 4 terms in it. So we're going to go through now and write, so we're going to leave k in there, okay, so that we can calculate each term. This is the formula for calculating the terms within the binomial expansion that we're looking at. Okay, 3 minus k and y. Oh, and actually, let's not do that. Let's go back. I'm going to substitute those in right now too. So what is x? So x is 2x. 2x raised to the 3, remember that's my n value is 3, minus k, I leave k. And then y is negative 3 times negative 3 to the k. Okay, so this is a really important step, so let's write it out in words as well in your notes right here. Okay, so you're going to write out your binomial theorem, substitute in n, x, and y, but leave k as k. K is going to tell you which term you are substituting. Okay, so let's get different colors for this so we can kind of see what I'm talking about. Okay, so the first term in your binomial is going to be, so there's going to be 4 terms. Remember we talked about it was when k is 0, k is 1, k is 2, k is 3. This summation tells you which one's the first term. It starts at k equals 0, and it goes up to the third when you have 3 written in there, okay? Okay, so let's start right here. If k, oh, that's the wrong thing. That's why it's not working, sorry. Nope, nope, nope. I just want this, and I want that. Okay, so if k equals 0, okay, that's the first term. So we take this whole thing and we plug in a 0 everywhere there's a k. So I have 3, choose 0, 2x. Now remember, there's an x substituted in for x, and so that's okay. So when I say substitute for x, just whatever this first term is, right? 3 minus 0 and negative 3 to the third power. Okay, so I've taken this exact thing right here, and all I've done is substitute in the k equals 0. Okay, so now let's change to another color so you can see the second term, and we're going to calculate these two, but would be when k equals 1. That would be the next term in the sequence. So when k equals 1, you'd have 3, 1 at a time. We're plugging in the k right here. Then we would have the 2x raised to the 3 minus 2 and negative 3 raised to the 3. Okay, so what do you think the next term is going to be then? If we have to go to the next term, that's a really ugly green, oh boy, this one, is when k equals 2. Okay, and you keep going for each term depending on how many terms you have. So this would be 3, taken 2 at a time, 2x to the 3 minus, oh, I wrote 3 minus 2 right here, but you guys didn't stop me. Wait, what did I do? 3 minus k should have been 3 minus 1. Guys, man, lots of mistakes back here. Let's go back to this one. Come on. There we go. Let's fix this one real quick. Sorry if that was confusing. Let's see. This one is wrong too. Well, let's go back. Let's fix it. Okay, so this one, let's go back in this. This was k, 2x. This should be 3 minus k is 1. This one should be negative 3 to the first power because k is 1. Okay, fix that one. Now let's look at this one. Sometimes I have trouble talking and writing at the same time. 3, where this is the k, is 0. 2x, 3 minus 0, and negative 3 to the 0 power. Okay, now let's look at this green one. See how much I watched this one. Then you'll have 3 taken 2 at a time, 2x to the 3 minus 2, negative 3 raised to the second power. Okay, I'm gonna, I should have chosen one with 3. I can't even fit all of these on here, and because of time, we're just gonna calculate a few of them, okay? And then we're gonna show you how if you just need one term. Okay, so the first term would be 3 taken 0 at a time. So remember, this means 3 factorial over 3 minus 0 factorial divided by 0 factorial times 2x to the 3 minus 0 power, which is 3, and negative 3 to the 0 power. Okay, so this is just for one term of your binomial expansion. So we're going to take this now and we're going to simplify everything down. So this is 3 factorial. What's 3 minus 0 is just 3 factorial. So we get 3 factorial divided by 3 factorial. And 0 factorial, remember, is 1. So this is times 1. So these all cancel. This whole thing equals 1. So now we have 2x to the third. Remember, if there's an exponent outside of parentheses, you have to raise both of these to the third power. So I get 2 cubed is 8. X cubed is x cubed. And then negative 3 to the 0 power equals 1. Okay, so we have 1 times 8x cubed. Okay, so that first term is 8x cubed. Whew, we got it. okay? All right, the second term. And if you're going to calculate the entire thing, you would have to do each term. Okay, so this one is going to be 3 factorial divided by 3 minus 1 factorial times 1 factorial. Okay, this is following that formula from last time. This one's going to be 2x raised to the 3 minus 1, which is 2, and times the negative 3 to the first power, which is just negative 3. Okay, here we're going to start canceling these out. This would be 3 factorial, which is, actually, I'm not going to write it like that. I'm going to write it like this. 3 times 2 times 1 over 2 factorial, which is 2 times 1, times 1. These cancel all the 1s. You're left with just a 3 there. And this is 4x, right? Because you have to do 2 squared, 4x squared. We'll just keep it like that. 4x squared times negative 3. Okay, so now we have the 3 times the 3 is negative 9 times 4 is negative 36. So this second term is actually not a plus. It is a minus because the term came out negative, right? So this would be minus 36x squared. Okay, that's the second term. Got the second term. Okay, next we've got to go through and do the third term. Okay, so do you see the process that I was going through here? And then you'd have to do k equals 3, and you would go through and find this one, and then you would find this one. Okay, so this would be when k equals 2. You would find what that value is, and here you would find when k equals 3. This is labor intensive, I'm not going to lie. It's a lot of work, right? Okay, let's look at one more thing. I'm not going to calculate all of those right now, just because of time. So let's do one more example of finding just one term within the binomial theorem. Okay, so let's look at just one last example. If we're asked to find the 13th term of a plus b to the 27th power. Okay, now first of all, the first thing we need is to write out the binomial theorem. And remember that we're creating it's a formula for finding each term, right? I showed you that in the last one. So we need this written out, where k equals 0 is your first term. K equals 0 is my first term. I go to the 27th term, and it's going to be n, taking k at a time. Remember, I replace everything except for the k. Okay, so n is 27, taken k at a time, because that's going to tell me which term I'm on. Okay, and then I have x. Well, x is going to be whatever in this first place. So a to the n minus k. Oh, and n is 27. Replace all the n's. So I have 27 minus k. My mouse is starting to die, sorry. It's having like little glitches. 27 minus k. Oh, I might have just been on a wavy part of my table. Okay, so then we have b is going to be to the k power. Okay, so once you write your formula, we're leaving the k's but replacing the x, the y, and the n. Okay, so let's ask for the 13th term. Let's talk about this again. This is where your mind always has to think with these summations of where you're at. The 13th term. The first term is 0. So if the first term is 0, the second term is when k equals 1. The third term is when k equals 2. See how it's 1 less because we started at 0 instead of 1. So if we want to find the 13th term, then we need to find when k equals 12. Okay, now let's say that one more time. If we want the 13th term, because k equals 0 is the first term is 0, then 1, then 2, 3, 4, 5. When you get up to 13, you're actually only to k equals 12 because there you had to add on that 0 as well. Okay, so k equals 12. So then here, from this point, you can have your, just kidding, don't write that. I don't want to write the whole thing out again. So when k equals 12, we're finding just that term. We're going to take this formula and we're going to replace a k equals 12 in anywhere where it says k. so 27 taken 12 at a time, a to the 27 minus 12, and b to the 12. Okay, now we calculate this all out. So this would be a 27 factorial over 27 minus 12 factorial divided by 12 factorial. I'm going to make that my 12, sorry. That's, you guys, come on. 12 factorial. All right. Okay, then 27 minus 12, which is what? 15? 27, so 2 minus 7 gets down to 5, so it should be 15. And add b times b to the 12. Okay, so then you would go through and calculate this. You simplify down your factorials, you would get a number, and your term would be a to the 15th, b to the 12th. Okay. Awesome. So we're going to try this in class. This is going to take a little bit of practice, so we will see you in class, and we'll do more of them.